Welcome to the another video. So today we'll discuss what is the basic elements like node, maze, loop and branch. So as you know that in KCL we told about node. So basically node is a meeting point of two or more circuit elements. So circuit elements already I told about active and passive circuit elements. So if there is meeting point of two or more than two circuit elements, that is called node. Similarly, branch is nothing but the part of the network which lies between two nodes. Then you come to loop. So loop basically is a closed path in a circuit which no element or node encountered more than once. Okay, so all these things I'll explain with some example. Then the fourth one is come mesh. So mesh basically it is a loop that contains no other loop within it. Okay, so what is loop, what is mesh, what is branch and node, that we will discuss with the example. So now again this node is divided into two types. One is simple node, another is principal node. So basically in simple node, if two elements, so if two elements are the meeting point of two elements is called simple node. In the principal node, basically we will take three or more, three or more circuit elements if they're meeting, that is called principal node. Okay, so now you can see the first example here. You can see this is a voltage source. There is five resistors are connected here. Now we need to find out how many nodes are there, how many principal nodes are there, how many simple nodes, how many principal nodes, how many branches are there, how many meshes are there, and how many loops are there. Now you can see here, so this point marked in blue color. So this is a node. So this is called simple node. Similarly, this is also called simple node. So I am denoting as SN. That is called simple nodes. Which basically this is the meeting point of two elements. Okay. Now you can see here. So this is simple node. Also this one is also simple node. Only two elements are meeting here, R4 and R5 made. So I can write down this is the first simple node, this is second simple node, and this is the third simple node. As I told, the principal nodes are what? Those are three or more elements are connected. So you can see here, this is one principal node and this is another principal node. So here in this principal node, R3, R5 and this V. So you can, if you have a doubt also, sir, this is also a node. But no, here this voltage and this R3 and R5, this node is connected. Suppose I am naming as this is node A, this is node B. So you can see node A and node B both are connected through a conducting wire. So you can say that node A is equal to node B, or I can do like this. I can remove this node, or I can connect this node like this in a simple circuit. So I can connect like this. So it will be easier now. So now I can find out how many nodes are there. So this is one principal node. So I can put here, this is also a principal node. Okay. So total five nodes I can get. So I can get total five nodes. So nodes are five, out of which three are simple nodes, two are principal nodes. How many branches are there? I told branch is nothing but the part of a circuit which is in between nodes. Now you can find out. I am putting this pink color. So this is the first branch in R1. So this is the second branch. So which is in between this principal node and this simple node. So this is the second branch. This is the third branch. This is the fourth branch. This is the fifth branch, and this is the sixth branch. So total number of branches we can calculate equal to 6. Then come to loop. Okay. So when we calculate loops, so loop is nothing but a closed path in circuit which no element or node encountered more than once. So now you can see here, I have taken, this is the first loop where one voltage source is there, R1 is there, R3 is there. So this is your loop 1. Similarly, you can say this is also a loop, it is a closed path where R3, R2, R4 and R5 comes once. So this is your loop 2. Then I can take all together. I can take all together. This is also another loop. I can say this is loop 3, where I have taken V, R1, R2, R4 and R5. So I can write down here number of loop equal to 3. Okay. Then question comes, how many number of meshes are there? So mesh is that. So basically mesh is a loop where it doesn't contain any other loop. So you can see out of these three loops, only this loop 1 and loop 2 doesn't have any other loop inside it. But loop 3 contains loop 1 and loop 2. So basically we are getting two meshes. So this is your mesh number 1, I am putting in red, and this is mesh number 2. So I am getting totally 2 mesh, 3 loops, 6 branches and 5 nodes. So I can take another example also. So you can see here, this is another example. So one voltage source, resistor, capacitor and inductor connected in parallel. Now the question is to find out how many number of nodes are there, how many number of branches are there, how many number of meshes are there, and how many number of loops are there. So you can see here there is 1, 2, 3, 4. So 4 elements are there. So 4 elements are connected in this parallel order. Okay. So now you can see. So you can see here this is a meeting point. Here this is a meeting point. Here also this is a meeting point. Here also this is a meeting point. Okay. Similarly, you can see this is also some meeting points. Okay. So you can see here all are in this blue. So I'll put it, this is let 1, 2, 3, 4. So this 1, 2, 3, 4, these nodes are nothing but similar nodes. Okay. So you can see in between 1 and 2 there is no element is there. So basically 1 and 2 are connected in a simple conducting wire. 2 and 3 also connected in same conducting wire. So you can write down 1 is equal to 2 equal to 3 and 4. These are all same nodes. So I can do one thing. I can erase these things. So this 1, 2, 3, 4 instead of writing like this. So I can join all these wires in this fashion. So you can see now. So this 1, 2, 3, 4 all the nodes are same. So I can get this is a basically one node. So this is called principal node. Same thing I can do in the bottom also. So this node, this node, this node all are same. So now I can do one thing. Same thing I can do. I can erase these things. Okay, as they are connected, it's a simple conductor. So I can do like this. Okay, so you can see here the circuit is same. So I can get two principal nodes here. So nodes I am getting here, total number of nodes I am getting 2. So how many branches are there? You can see. So in between two nodes there are 4 circuit elements are there. So you can say this is your first branch, this is second branch, this is third branch, this is fourth branch. Okay, so I can find out branch equal to 4. Now, how many number of meshes are there, or how many number of loops are there? So you can see this is one loop, so loop number 1. This is another loop, loop number 2. This is another loop, loop number 3. So by taking these two, okay, by taking these elements, so I can find out this is loop number 3. I can take by connecting this also, I can get another loop. Okay, so I'll get loop number 4 here. Okay, so by taking all the elements, by taking all the elements together, I can get here loop number 5. Okay, so basically okay, then any other loop we can take. So 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. I forget 1, 2, 3. So be a small mistake here. So I get this is 4, this is fifth number loop, this is sixth number loop. Okay, so 1 I'm getting here, loop 1, this is loop 2, this is loop 3. So by taking this is loop 4, this is loop 5, and this is loop 6. So total number of loops I'll get 6. So if you want to find out how many number of meshes are there, so you can see this is mesh 1, This is your mesh 2 and this is your mesh 3. So meshes are nothing but the loops where inside that there is no other loop. So total number of meshes are 3. Okay. Similarly, you can take any branch, you can take any circuit, you can find out number of nodes, branches, loops, and mesh. So this basic is very important in point of view if you will calculate the nodal analysis or mesh analysis. If you have any doubt, you can ask in comments also. Thank you.